a lot warmer out yesterday afternoon than I thought it was going to be. So let us take a look at angles. What is an angle?
An angle. Something. It's like.
What is it made? How about this? What is it made up of? What's that? Degrees. Okay, angles are measured in degrees. You know how else angles can be measured? Radians. Very good. But what makes an angle? Think about what it looks like. What is it? What's it called? Yeah, what is it called? What things intersect?
Two lines that intersect.
Not necessarily lines.
Two rays or
Yeah, that's right. Two rays. Okay. Two rays. Yes, sir.
And they cannot be on the same. It cannot be the one like two rays on the top of each other.
Yes, it can.
Well, yeah.
So angles. Basically, you guys all have seen this before. Angles are just two different rays that share a common endpoint. That's it. Angles are two different rays that share a common endpoint. These rays don't necessarily have to go in the same. Don't necessarily have to go in the same direction. They can go in opposite directions. They can go turn off one way. You had mentioned, Matthew had mentioned degree measurement. What is, when you're talking about degrees normally within the angles, bless you, how many degrees do we usually keep it within? You go 180, but a lot of times in geometry, we keep things within 360 degrees. That's basically what we look at in geometry. When you get to Algebra 2, we tend to steer away from degree measurements. We start talking in Turkey, Turkey too, Turkey and Turkey lock.
Turkey country.
So when we get into Algebra 2, we no longer worry so much about degree measurement. We start talking about what's called radian measure. And that's when you're talking about what's called the unit circle. That's more of a standard. It's kind of like, you know how America is the only one that really uses the English version of measurement? Inches and feet and pounds and ounces and all that, where everybody else uses the metric system. It's kind of the same idea with degree measurements. Degree measurements is more of a basic, whereas radian measure is more of a specific. So that's why we talk about that. Don't concern yourself with that right now, but it'll be there eventually. So angles are two different rays that have the same endpoint. Where those two different rays, that common endpoint that they share, that's always called the vertex. Okay? And then the sides of an angle are just the rays that make it up. Now I put a little note in here about labels. And labeling angles is really important for how you know what you're looking at. And this is kind of the one, I don't want to say tricky part, but it's the one part that students can easily mess up if they're not careful with it. So when we talk about angle measurements, when we talk about angles themselves, they're labeled usually with 3 letters. We'll just call this angle A, B, C. And the way that we write this, I write it a little bit different than just, well, you probably need to do this. When I label my angles, I do this. I put a little arc in my angle. That's old school.
It is old school.
It's very old school.
Now, why do you do that as opposed to just?
Because if I don't do that, sometimes it looks like a C, sometimes it looks like an L. It looks like an upside down 7. So to me, when I was taught geometry back in the, it would have been, are you ready for this one? It would have been the fall of 1989 for my high school geometry class.
Okay, I was teaching at the high school.
There you are. So my high school geometry class was the fall of 1989. So you can do the math there.
Well, you taught in 1989.
Yeah, I look that good for being this old. Just like Mrs. Thrower.
No, he was in high school.
That's who
He was in high school.
you say
I was
compliment.
teaching.
She didn't hear it. You missed out on the compliment.
Oh, okay.
Say it again.
What?
You said, so you thought I was teaching in 89. I said, yes, I look that good for being around since that long, just like Mrs. Thrower.
Here you go.
Is that why you look like a 102-year-old man?
102-year-old man? Yes. At 102 years old, I'll still run circles around you. So there you go.
And how many degrees are in that circle?
Challenging
No!
to raise.
All right. Anyway, so when we label
Mr.
certain,
Murphy,
yes, sir.
if that's the way you want to do it, I challenge you to a mile run.
A mile run?
Yeah.
Sure.
All
What do you
right.
want to do?
Casual. Tomorrow morning.
I'm busy tomorrow morning. I got to drop my son off at school, but we'll schedule it. No problem.
Hey,
I'll run a mile.
I'll
against
run
you.
with
And
you.
we're all gonna be there.
It's fine.
Eric makes me feel like you're gonna win.
Do you want me to wear a shirt and tie?
Then if you do that, then
There's
then
no
you will just be
competition.
thrown down, and there's no point of winning.
Okay. Anyway, so back to labeling these things. When we label our angles, there's what we usually label them, I'd say 90% of the time with 3 letters. 90% of the time we label all our angles with 3 letters. That tells us direction. So if I say angle A, B, C, that tells me it starts at A, goes to the vertex of B through C, which means the second letter is always the vertex. The second letter, when you label out angles, please put your feet down. Thank you. The second letter will always be your vertex because it's telling you where it's changing direction. A, B, C. If I say C, B, A, is it the same angle?
Yeah.
Yeah, it's the same thing. You just go the other direction. So you can flip-flop the letters on the sides of the for the sides of the angles, just as long as the vertex is the same. You're okay. All right, you're okay. Another way that you can do this, the only time you can do this, is I could also label this as angle B. And the reason that I can say that that is angle B is because is there any other angle that in this picture that has B as the vertex? No. Whereas in time, we'll have stuff that looks like this, where you'll have I can't call it angle B here because I have, well, here's an angle B, here's an angle B, here's an angle B, here's an angle B. There's at least, what, 6 of those here. Yes, sir?
Okay, so I already know. Angle B, angle A, B, C, and angle E, B, D have the same angle, as well as C, B, D, and A, B, E have the same angle.
Measure. Same angle measurement. You're right, because of what we call vertical. And then we'll get to all that later on when we start talking about angle pair relationships. So yes, you're right. So when we see something like this, where you have multiple vertices, if you will, you have to use 3 letters. Does that seem normal? You'll see a lot of times when we start talking about triangles that we will use 1 letter with triangles a lot of times with the angles, because there's one angle here, one angle here.
Mr. Murphy, are they ever labeled with numbers, or is that?
That does happen as well. We get a lot of problems where you'll have big picture problems where you'll have a whole bunch of different angles, like 1, 2, 3, 4, 5, and they'll ask you to say, hey, what's the measure of angle 2? And eventually we'll be able to do some math to figure that kind of stuff out. So you'll see that as well. But generally speaking, angles are written out usually with capital letters again, just like you would with array. 3 letters, middle one is always the vertex. If we keep that straight, we're going to be fine. All right? There are types of angles. Now, for our class, usually we're going to keep our angles within 3 types. Well, actually 4. So
Right angle,
we have a right angle, very good.
obtuse,
Okay. So we have what's called a right angle.
obtuse.
Are we okay if I label it like that?
No. Except for right angle doesn't quite look like that. It has a 90 degree.
Yeah, I will. This means I abbreviate a lot, so this just stands for a right angle. What does a right angle measure?
90 degrees.
90 degrees. All right angles measure,
90 degrees.
otherwise known as pi over 2.
And every corner fits. You're cold, you ever cold in this classroom? You always sit in the corner.
Boo.
It's 90 degrees. Now I get the joke.
So right angles always measure 90 degrees. Are you a right angle if you're 89.999?
Yes.
No. It has to measure exactly 90. Okay. What's another type of
Acute.
acute? Why is it acute? What does it measure?
Less than 90 degrees.
Less than 90 degrees.
An acute angle is an angle that is measures between greater than 0 but less than 90. So it's an angle whose measurement is greater than 0 but less than 90. So it's between 0 and 90. Okay. Notice it's not equal to. Because if it equaled 0, would it be an angle?
No. It would.
You wouldn't have it. You'd have a segment, yeah. Well, then well, we can get into the specifics. It gets weird. So an acute angle, they call it acute because it's little.
It's little. No.
Then you have
Better than 90 degrees. I was waiting for you to boo me.
So, like, when I was pregnant with Sam and Alex back in the early 90s, I was working with Mr. Swift. Do you remember Mr. Swift, Jack Swift, our wrestling coach? He always referred to me as an example of the next angle that you're going to talk about. And I know you would never do that, Mr. Swift.
No way.
obtuse.
The obtuse. An obtuse angle is an angle that measures between what and what? 90 and 180. Yeah. An obtuse angle is an angle whose measurement is greater than 90 degrees, but it's less than 180. Now, do you guys see why I put that little arc in my angle now? So we start talking about it in terms of less than symbols and all that. The less than symbol looks a whole heck of a lot like an angle symbol if you're not careful with it. All right. And then last but not least, you have the last one. Otherwise known as dun, dun, dun.
Or 180.
What do you call that one? It's a line or it's a segment, but what do you call that in terms of an angle? What do you call it? Straight angle. Yeah. A straight angle. You have what's called a straight angle. Okay.
A straight angle.
Anything good? You were taking notes. What are you doing?
Brandon, what are you doing back there?
No, it's just one.
You have what's called a straight angle. Straight angle always measures 180 degrees. In this class, we generally don't go greater than 180 degrees. You can, but there's really no reason for us to. Next year, like I said, in Algebra 2, we spend, I don't know, I'd say a good, I know in my honors class, I'll spend a good almost 2 months in just angles and trigonometry and stuff like that, where you live on what's called a unit circle, which is the basis of all trigonometry. And its basis is all about, you guys know what reflection is? Where you flip things across axes and stuff? It's just 3 different angles cycled throughout one revolution.
I have a question. So with angles, the concept, mean that we have 2 poles on the Earth, with angles.
I don't know on that. I'm not sure on that one.
Okay. I was just wondering.
Yeah, I'm not sure on that. G, what do you think angle addition is going to look like?
That.
Yeah. What do you think it's going to mirror? Segments. Hey guys, when we had segment addition, 2 smaller segments added up to equal the larger, correct? What do you think happens with angles?
Same thing.
The same exact same.
Same thing.
The same thing. So angle addition is nothing more than 2 smaller angles add to equal larger. Now, I will say one thing. When we wrote out the steps, remember when we wrote out the steps of the segment addition, and It was really nice, and we had 2 letters for each segment, and you add them together, and you got 2 more letters, and the letters mirrored each other. With angles, when you write it out, it can get messy if you're not careful. So please, when we're working with angle stuff, try your best to use clearer penmanship, because it's very easy to get lost in what you write with angles. I see it all the time, okay? So in this example here, does everybody agree that there are 3 angles? We have this one here, this one here, and then the big one in between. Are we okay with that? So in order for me to write this out in terms of angle addition, well, what's the first small angle? A what? Not AD. AD would be a segment. ABD. So what I would write, let me move this over just a little bit. I would say that angle, let me change this. Angle ABD plus, what's the next small angle? Angle DBC, very good. Equals the large angle, which is ABC. Now take a look at what they all have in common. They all have the letter B in common, don't they? And notice with the letter B, what is the letter B for all 3 of those angles? Vertex, very good. You have the vertex being the second letter, and it's the same every time. And that's the idea of animation. That's how this works. Okay? So if I said that angle, for example, if angle ABD, if this angle here measured 33 degrees and the whole thing was 96, what would you do to figure out what the other angle was? That's all it is. See how it's the exact same thing as second addition? You're just not turning. You're not going straight, you're turning. That's it. It's the exact same thing. So you could write out 33 plus something is 96. And you get that 1-step equation. Is it going to be the end of the world if you forget to put the degree symbol?
Yes.
No. By all means, when we're doing this stuff, if you forget to put the degree symbol, it really isn't the end of the world. Okay? It really isn't. Really. I'm
But in
not,
science class, if you don't label your numbers,
Yeah,
the
science-
measurement, right?
that's why nobody likes the science people.
Yeah, but isn't that
I'm joking because my wife's a science
Oh.
teacher. Really. She is really.
I hate it. It's so hard.
You know what though? There are some science classes that are hard. I hated biology. Biology was I loathed biology. But you know what though? There's actual practical stuff about that because you can learn how to measure distances. You can know how to do that. If you guys have any aptitude in math and you kind of like science a little bit, or you want to try something, take a physics class. Physics is such the pure application of any math problem. You get to build stuff and you see how numbers relate to real life problems. I remember my physics class, and I know they do this stuff here. They build catapults, they build mousetrap race cars, we used to drop egg parachutes and stuff like that. We had to create stuff like that. We build balsa wood bridges. You use formulas, force, gravity, all these different formulas that deal with math to help design, and you create your own stuff using that information. I loved my physics class. I had a ton of fun with it because it was, I don't want to use the word physical, but it was a pure physical science where you can actually, yeah. And I thought that was just really, really cool. Another quick example. Take a second and solve it.
just the way he is. He would look like this. He'd be like this.
Door.
Don't let him in, don't let him in.
Is it?
Oh, okay.
No.
No.
No! Oh! Boo.
What's so bad about me?
Oh, I didn't know it was you.
What you say? Let me get on this for you.
What is so bad about me?
So, when we look at this, when we look at this, enough guys.
Okay, now I'm more awake.
That's the whole 110, isn't it?
Yeah.
Okay. So we know that the whole thing is 110. This much is 35. So all I do is 110 minus 35. Dun dun dun. What do you get?
Equal 80. 5.
How much? Get a calculator. Okay. Now, will any of this stuff change when you throw in algebra?
It's just gonna take longer time.
That's it. Is anything going to change when you throw an algebra problem into this?
Yes.
Did anything change when you had the algebra with the segment additions? No. None of that changed, guys. It's all the exact same problem. What you know is that you have two smaller chunks add up to equal the whole. It does not change the setup. It does not change the addition, the subtraction, the two steps that you might take to solve it. None of that changes whatsoever. It is going to be quite literally the exact same scenario as segment additions. Nothing is different except for the fact you hit a vertex and you change direction. That's it. Okay? That's the only thing that's different. So in this case here, we have given measure of angle NRQ is 78 degrees. And notice, they throw in the geometry part. Not just solve for x, they're asking you to figure out the measure of angle PRQ. So, we know that NRQ is made up of what two angles? NRP and PRQ, very good. So what we can do is we can write it out long form, knowing that angle NRP plus angle PRQ has to equal NRQ. Now, I will suggest, well, obviously, in this case, you notice how it can get really, really messy. If you guys totally understand where these things, how the two smaller add up to the large, and you don't want to write out that step because it's very easy to get lost in the letters, it's okay. Because I know it's very easy to get lost in the letters. It does. All right? So let's see. NRP is 8x plus 7 plus 4x minus 1. And what was it, 78? Okay. You go. Take a second. And then you wanted to find NRP. PRQ. Not PDQ, but pretty darn quick.
Secret size me. Is he bad like a baby? That's good. She just get out.
What's the matter? What's the right thing? Where's the matter? For this morning. Let's come up with some more. getting any notes now?
If you'd like, it would be great if somebody else would like to go through the problem for me.
So I read X, plug it in.
Yes. We're gonna do whatever the expression is for PRQ.
Whoa.
Okay, go for it.
You got what? Got some 23. Actually, six.
So I'm talking to my man's at he calls me every time. I still get in more than his ass. You know, I play defense. You can really play defense. Like, you get into the rim.
Do the right
Steps.
steps. Mr.
If you're gonna dribble much, you need
You forgot to add like terms.
Ladies and gentlemen,
Go ahead, Sal, for us.
guys,
Don't.
Now, okay, that's not answering the
I
question.
did.
Now, Austin, do the
Interrupt
next
me.
step. Austin, do the next step. Plug it in and find the
Yeah.
answer of PRQ.
So for this one, nope.
PRQ.
Oh, shoot. So that would be, PRQ would be 23.
Yep.
If you plug it in, you get 24, and then you just
I wasn't wrong.
subtract 1, which will give you 23.
23 what?
Degrees. You don't want to write any words.
I appreciate that.
What's
So
up?
when
Expression
PRQ,
of degrees in the
Put a little
depth.
difference to it.
circle on
Dang, everyone's saying at once. Okay, the world will go on.
That's fine. Yeah. Hey, just real fast, guys. One of the things that he did here was that he, instead of combining his terms right at once, which most people would do, he subtracted the 7 and then he added the 1. So he did that in 2 steps as opposed to most people. I think most people just said, hey, let's just subtract subtract 6. Did everybody see how that worked? Because that's one of the steps that most people don't do that. There's nothing wrong with it. But I just want to make sure you guys understood that's where you got those numbers from. Okay. Cool. Thank you, sir. See, you can slow down. It works out. Gee, what do you think this does? What do you think a bisector does? What does a bisector do of a segment? Put away your phone and stop playing video games. Close your computer. You're sitting here like this. You don't think I know what you're doing? Come on, put it away. Close your laptop. Let's go. All the way. All the way. Then move your phone. Put it in your pocket. You got one right here.
Brandon, don't be irresponsible. We don't have time.
Angle bisector. Gee, do you think it's going to do the exact same thing as a second bisector? Does the same thing. So an angle bisector, it cuts an angle into 2 congruent angles. That's it. Into 2 congruent angles. Remember, congruent means equal measure. So if I have an angle bisector and my angle was 120 degrees and I cut the 120 degrees in half, what do both angles become? 60s. 60s. Okay. Angle bisector, all it does so this is A, B, C, and D. So if ray BD bisects angle ABC, therefore, what 2 angles become congruent? Yep. That's all it means, guys. Notice the second letter is still the vertex for all of those. It just says that those two angles will be the same measurement. Angle bisectors cut angles into two congruent parts. Just like a segment bisector. Segment bisector cut two segments, or cut a segment into two congruent parts. It does the same thing. So this is very nice that we're talking about the angle bisectors, the angle addition, right after we got done talking about segment addition, segment bisectors, because they mean this. So hopefully this isn't really all that terrible. I'm hoping. Let me show you. You get better. No worries. Seriously, no worries. It's one of those things. You know, I got little tricks that I'll show you guys as we go along.
Could you go back real quick?
Oh, yeah, real quick. There you go. Oh, you wanted it longer than that. Sorry. You didn't specify time. Yes, sir. That's fine. Brandon.
Don't take that with
We should just say it last
I'll
time.
hold it for you.
There's someone watch Brandon.
you. You won't take it.
Hey, I want a black coffee, please.
Anyway, so let's look at an example.
Black coffee? Yeah, boys.
In this example, it says that BD bisects ABC. Now, one of the things that comes up all the time in this book is that people freak out when they see the exclamation point.
Whoa.
They're not yelling, 11x minus 12! They're not doing that. They're not doing that. It's not, guys, it's not affecting me. Hold on. It is not yelling at you. It is not mad at you. It's not angry at you. For some strange, odd reason, when they went from degree symbols to the typesetting into some of these worksheets that I have online, it started yelling at you. It's not angry. It's not yelling.
It's just like excited.
It's very, yes, it's excited. It's happy to be there.
Yay, England.
Yay, angles, woo! So, if angle BD, if ray BD bisected it, all you have to be able to do then is know that, well, that means those two angles are the same. Remember how we did tick marks with segments? We use arcs for angles. Okay? So algebraically then, I have to do the exact same thing when we work with the algebra for segments. All we have to do is set these equal to each other. 11x minus 12 is 8x plus 3. And we solve that for x. It's the exact same thing, ladies and gentlemen. So if you had problems and you were still messing up a little segment addition, segment bisectors, all that, gee, guess what? You get more practice at it today.
Got it.
All right? Variables on both sides of the equation, who are you going to pick on?
Well,
Pick on the little guy. So we're going to subtract the 8x. At the exact same time. What's that?
If you subtracted like the 11, wouldn't you still get
You get the same answer, but the problem is a lot of times you have to remember you have all those negatives.
Yeah.
So you just got to be careful with the negatives, that's all. By doing by working on with the little guy, you're less likely to have to deal with the negative.
Yeah.
That's all. I'm going to add 12 at the same time.
It makes it more complicated.
And you get 5. And then it's a matter of just substituting back in to get your angles. Should those two angle measurements be exactly the same if you substitute back in? Yes, they should be. So 11 times 5 is how much?
55.
55 minus 12 is
43.
So here's 43. So 5 times 8 is
40.
40 plus 3 is?
43.
Look at that, we math.
Nice.
Now, Mr. Murphy, I have a question. So if they ask you what angle, the measure of angle ABC was, do you recommend that students go ahead and plug X into both
Yes.
expressions?
Always, always, always. Because that way you will know for certain
Right.
if you guys didn't done goof. All right.
Always.
So you always want to throw it into both parts just to make your lives easier. Just to make sure. Yes, sir. Never mind. we also start to get into stuff that looks like this. As we start to walk through things, yes, sir. I don't think you've earned it. In this case here, do you know what that little box means? The right angle. How much does that measure?
90 degrees.
Measure 90 degrees. Now, give me 1 second, okay, please? Austin, put your arm down, please. Thank you. Now, one of the things that I want you guys to take into consideration when you start getting these big problem style diagrams is that to look at one spot. If I know that a straight line is 180 degrees, if this much was 160, how much do I have left to get here? 20. Which means if this is a straight line, how much do I have left to get back to B?
160.
160. Now, Austin, this goes back to what you were talking about a second ago. In this case, you have what are called two sets of opposite rays, same vertex, therefore you have what are called vertical angles. We talk about that tomorrow, about why that works. Okay? Same deal here. We know that this is 90 degrees, we know this is 90 degrees, and I know that all three of those angles have to add up to equal how much?
180.
180. Good. So if I subtract out the 90, how much is left for these two?
90.
90. That also has to be 90, doesn't it?
So that would be 15.
Yeah, that's
Correct.
what I said.
Now, you can do a couple of different things with these. You don't necessarily have to add just two angles to add up to large. You can add up 3 of them, 4 of them, 5 of them, whatever. It still works the same. Okay? So when you do that, excuse me, we again have 90, 75, and C becomes 15. So you can kind of go through the same idea here. This angle D, since this guy mirrors itself here, also winds up being 75. For some reason, I think I took this picture from 1.5 because you kind of have to use vertical angles here. I think I might have bumped through a little bit here. Oh well, no big deal. All right. This is kind of what we're getting to. I mean, it's going to be, tomorrow we'll talk about complementary and supplementary, which I know you guys have done as well. Yes, sir.
There was an equation that I came up with in 6th grade. It was the only equation that I actually came up with by myself. For like finding the missing like thing.
We'll talk about that later when we start talking about linear pairs then. Okay. I believe this is what I had for homework. Let me double check what I put online. Again, guys, 1.4 here. Yep, it was it. Bless you. It was the same thing. It was page 29 in the book, 22 through 27.
That's it.
22 through 27 on page what?
It's on the calendar. It's the same thing. Page 29 in the book, 22 through 27, 29 through 31, 33 through 42. I tried to do on the calendar thing a direct link for the page. I don't know if it worked. You might have to copy and paste it. You've got your Chromebook right there. It's on the calendar. You guys all know where the calendar is, right? It's on the website.
It's on that home page and you just scroll
Yes,
down,
sir.
correct?
It's convenient, isn't it? I think it's the same one here, 32, 31. Yeah, it's so 29 to 31. Okay? We'll do those for tomorrow. You guys got a good, well, actually I thought we had more time than that. Sorry. We got a couple minutes, whatever, but from there tomorrow we're going to talk about complementary and supplementary. Do you remember what those were?
I mean, probably Jason. I don't know. Jason.
You'll remember when we get into them tomorrow. All right? They're really, really easy. Okay?